nanotech and biology. You know, the image that is of the future that's portrayed by kind of one of your colleagues, Ray Kurzweil, is sort of famous for doing this. But we're gonna have nanobots running around, cleaning up our our arteries and killing waste and so forth, and you know, and forms of drug delivery that will change dramatically. When we look at nanotechnology in your field, you know, what are we seeing and where are we headed?
Sure. Well, I think that, I mean, some things I think that people put out may be far-fetched in some cases, others not. I think in terms of nanotech and medicine, I think we are seeing a lot of exciting advances. I mean, just to go over a few, I mean, and maybe why also nanotech's important. Generally, if you want to get something to go inside a cell, probably has to be 200 nanometers or less. So so there's a lot of things we'd like to get inside cells. So just to pick a few examples that we and others are working on. I mean, one is cancer. It'd be great if you could develop a targeted nanoparticle. We actually have a big program with the National Cancer Institute on that, to target nanoparticles right to cancer cells and ideally no other cells. And that involves a variety of material science and engineering aspects, but that's an example. A second example in drug delivery is there's some new potential genetic medicines, things that could silence, for example, RNA. So one of the big advances in biology has been the discovery of substances that cause what's called RNA silencing. And if one could turn that into a therapeutic, and there already are clinical trials, again, nanotechnology offers the opportunity to deliver those RNA sequences to a cell to really shut off specific genes. It could lead to a whole range of specific new kinds of medicines that never existed before. And one might even think of multiple delivery someday of these things. And then I think there's a whole range of things in sensing and imaging that also nanotechnology can be important. And I think that nanotechnology, because the surface area of nanoparticles, again, is so much greater than larger particles. If there are physical phenomena going together, occurring, like, say, aggregation, that could create a signal, you can get a lot greater signal and therefore much greater sensitivity and possibly greater specificity by nanotechnology. So we're involved, for example, in companies that and findings that might lead to new point-of-care diagnostics, so that you could get very, very rapid, let's say there, for example, warnings for heart attacks, but right now, if you go to a hospital and look at those warnings, it might take 6 hours to get find out whether you have it or not. With some of these technologies, it may be possible in a few minutes, and that could change the way, for example, heart disease is treated. New imaging agents is another, much more sensitive imaging agents that could detect cancer early or other things. So I think there are actually a whole range of areas where nanotechnology is already in animal trials, in some cases in clinical trials. How it'll all play out is unclear, but I think there's no question, with so many different exciting things going on by people all over the world, that I have no doubt that with already the data that's in animals and people, and a lot of good publications in top journals, that the future is really exciting and very bright.
Regenerative medicine, tissue engineering. Give me a couple examples of things that really excite you on that front.
Sure. Well, just to go over what that area is for those who aren't familiar, I mean, it's sort of a broad-based way of saying, could we someday take cells, including stem cells, and someday create new tissues or organs? And already that's led to new skin for people who are burned, and new skin for patients who are diabetic and have, say, skin ulcers. But on the horizon, potentially, are many, many more things. One example could be new treatments for patients who are paralyzed, who have spinal cord problems. Another example could be, and again, new cartilage or new bone for people who have sports injuries or arthritis or other kinds of things. I mean, it's almost unlimited. I mean, if you think about it, there's so many organs and tissues we have in our bodies, and if they're destroyed or damaged, I mean, in many cases there aren't drugs, not even research on drugs, to fix them. I mean, so the only treatment is some type of surgery or some type of organ transplantation. And so liver would be another example. I mean, people.
Pancreas, right?
Pancreas is another one. Yeah, we're doing actually quite a lot of work on that also. And so if you could come up with a way to create a new tissue or organ, I mean, that would be a tremendous thing. And I think, and there's research going on in all of these things. In some cases, there have been approved products like in skin. In some cases, there are clinical trials, and in other cases, there are animal trials. But there's enormous activity, and I would say almost on every part of our body.
It's great stuff, but it's expensive, right?
Yes.
And you know, you've been involved in policy, obviously, and are an adventurer as well. How do you think about sort of where we draw the line in terms of incentives to innovate on one side of this, and yet the need to contain healthcare costs?
Sure.
Or, you know, is there a rule of thumb to apply? Is there, you know, how should we think about this?
Yeah, I haven't seen a really good analysis of, you know, that could be generalized. In other words, I think in particular cases you can look at it, and I think, you know, there could be examples of that. But I think there's a couple things to think about. One is, even though some of these things could be expensive, if you, I'll just pick Alzheimer's disease for a second. So people are looking at cell therapy for that. So you'd have to look at what's the cost of not having a treatment. In other words, how many people go to nursing homes, or in, you know, what is the cost of not having a medical treatment? And I think across the board, one has to look at, I think still today, far and away, the biggest costs are probably in hospitalization. I mean, no, I don't think they're drug costs. I think that that's certainly significant. But the biggest, but if you could keep people out of hospitals, if you could reduce those types of things and all the procedures that go with them, to me, that can also have a huge effect on decreasing the healthcare costs of the nation. And I think it's weighing those things. And I think in those cases where they're going to be weighed positively, clearly there's incentives even on a cost basis for figuring out, you know, better treatments. One story I like to tell, which I once read, which is interesting, is that Abraham Lincoln was once interviewed, and they asked him what were the 3 most important things in history. And he said, with 3 most important, it's a little bit self-serving what he said, but he said was the printing press, the discovery of America, that might be the self-serving part, and then he said the patent system. You know, that, and I imagine the reason he said it was for just the reason I said, that it just spurred enormous innovation. That said, I think that, to me, there are patents, and then there's also the judicial system that might enforce those patents. And I do think it's a balancing act. I do think, though, you really want to reward innovation. And I think that if patents are done right and patent examiners are given good instructions and understand these things, that will happen.
What personal lifestyle change have you made, or have you decided that, you know, looking at the evidence, and it's very difficult to, you know, to get, because you have one study that comes out, says one thing
Right.
comes out. Have you made any changes in your own kind of regimen that you were based said,
Sure.
you know, this is
Sure.
this is at least a 70% bet that
Sure.
it's right?
Well, for me, it goes back a long time ago. My dad passed away at when he was 61. That's the age I am now, of a heart attack. And you know, so what I did is I actually, a couple years later, I gave up red meat, which I used to love, a steak. And the other thing I've done increasingly over the years, now my wife thinks I'm crazy, is I exercise all the time. I probably exercise, you know, on the treadmill or the bike or lifting weights about 3 hours a day. I mean, I'm working a lot while I'm on the treadmill and stuff, you know. But I've made that change, and you know, I feel it. You know, it's a change I can't do is I'm not very good at the pushing the food away exercise. So
Well, then the 3 hours is unique, right?
yeah. So you know, and I'm not very good at giving up chocolate and things like that. So from my standpoint, I've you know, that's how I've tried to do it, is to you know, I always liked exercising and sports, and so I made that change, and that's kept my weight down a little bit.
Now,